Hello everyone, welcome to this video on cross correlation. In this video, we will see about the definition of cross correlation and its properties. In the succeeding videos, we will solve problems using these properties of cross correlation. Now we'll move on with the definition. What do we mean by cross correlation? Say suppose we are going to have two random processes, one given as x of t and the other one which has been given as y of t. So there are going to be two different random processes. Then the cross correlation between them is going to be defined as Rxy of tau t comma t plus tau r. Notice r, the first variable is x, the second variable is y, t comma t plus tau. So when we take the time difference or the delay in time, then it is nothing but t plus tau minus t. So this can be represented as r x y of tau. And the definition is the expected value of the product of x of t with y of t plus tau. So in the autocorrelation, we had both of them to come from the same random process called as x of t. But in cross correlation, they are going to come from two different processes. So what does this cross correlation actually measure? It is going to measure the similarity between a signal and a time delayed version of a second signal. So what happened in autocorrelation? It was a time delayed version of the same signal. But now over here we have a different version of it called as y of t taken from another random process. So when we compute the expected value of the product of the x of t with y of t plus tau, the outcome is referred as cross correlation. So for a cross correlation, first we take the signal x of t. Next, we have the signal to be y of t plus tau. The next thing, you compute the product between these two quantities, which is going to be given as x of t product y of t plus tau. And in the third step, what do? You do the expected value of the quantity. So when you take expectation to this product, so instead of 2x, we have 1x and the other one as y. So you write it as r, x, y, and the delay in time will be t plus tau minus t. So the difference will be equal to tau. That is the cross correlation which is going to be available for us. So the cross correlation of two signal is nothing but x of t product y of t plus tau's expected value. The next we move on to properties of cross correlation. When we have xy of tau, we replace this xy as yx. Then what happens to this tau? This tau gets replaced as minus tau. So Rxy of tau equal to Ryx of minus tau, which means that cross correlation is not an even function. So do we mean to say that it is an odd function? No, it is neither an odd function. So it is neither an odd nor an even function. But what happens over here? If xy of tau is replaced as yx, your tau gets replaced as minus tau. The second property says that if x of t and y of t are two random processes, then the cross correlation is less than or equal to rxx of 0 into ryy of 0's product, the whole square root. Rxx of 0 refers to the mean square value of your random variable x or the random process x, and ryy of 0 is nothing but the mean square value of the random variable y. So what do you do is, this is rxx of 0 is nothing but your expected value of x square of t. And what is your ryy of 0? It is nothing but expected value of y square of t. So what happens over here? When we compute the product of the mean square values and then take the square root, this will always be greater than the cross correlation's value. Property number 3, if x of t and y of t are going to be two random processes, then rxy is less than or equal to half of rxx of 0 plus ryy of 0. Here we computed the product of the square root of the value. Here we compute the average of the value. average of the value. We know that the value of e of x square of t, which denotes the mean square value, is always going to be a positive number. So when we are going to consider two positive numbers a and b, what happens is AB has an arithmetic mean as a plus b divided by 2. This is my arithmetic mean. And what will be its geometric mean? Geometric mean will be AB the whole square. So when for the two positive integers a and b, the arithmetic mean is a plus b by 2 and root over ab will be its geometric mean. And we know that always the value of which is going to be greater, the value of your arithmetic mean will always be greater than that of your geometric mean. That is, root AB will always be less than or equal to a plus b divided by 2. So this is nothing but the geometric mean of the two positive values, and this is going to be the average value or the arithmetic mean, and hence we can say on comparison that rxy is less than or equal to half into rxx of 0 plus ryy of 0. Now moving on, if the processes x of t and y of t are going to be orthogonal. Orthogonal meaning there is going to be 90 degrees phase shift between the two signals x of t and y of t. Then what happens to is cross correlation? The cross correlation vanishes or rxy of tau becomes equal to 0. The fifth property says that if the process x of t and y of t are going to be independent, independent means x of t can act separately and y of t can act separately. Then what happens to your exy of tau? They get separated as product mu x and mu y. How does this happen? We know that rxy of tau is nothing but the expected value of x of t product y of t plus tau. So what happens over here? If they are going to be independent, we know that e of xy is going to be equal to e of x product e of y. This is going to be the criteria only when your x and y are going to be independent. So in which case what happens? This gets separated as e of x of t and this gets separated as e of y of t plus tau. Y of t plus tau is just a time translation from your t, which means that e of y of t is in e of y of t plus tau remains to be the same. So what happens in the next step is that this is the representation of the mean of the random variable x and this is the representation of mean of the random variable y. Hence we have the cross correlation to be the product of the mean of x and mean of y when the quantities are going to be independent. Now we will apply these properties to a problem. Find the cross correlation of W of t and Z of t defined as A of t plus B of t, A of t minus B of t, where A and B are going to be statistically independent. Okay, so A and B are independent random variable. The next quantity given is they have zero mean. And the third quantity given is that they have been given an autocorrelation RAA and RBB, which is e power minus mod tau and 3 e power minus mod tau. Now our value is to find what is going to be the cross correlation. So we will begin. The cross correlation is going to be given by R of W Ez of tau. How do we evaluate this as E of W of t into Z of t plus tau. Now copy paste your W of t from the problem, which is going to be A of t plus B of t. Now this has to be producted with x of z of t plus tau. In your z, what you'll have to do is this t is replaced with t plus tau. So wherever we have t, let us replace with t plus tau. So this becomes a of t plus tau and the second quantity becomes b of t plus tau. So now we have to take the product of these two terms. So on expansion, they give us four terms. Let a of t go with a of t plus tau. Next a of t go with your b of t plus tau. So we will separate into four terms. A of expected value of a of t, a of t plus tau. This becomes my first term. There is a minus sign over here, so it becomes minus of expected value of a of t into b of t plus tau. Now going on with the second term, what happens? B of t, let us go with a of t plus tau and b of t goes with b of t plus tau. So now the third term becomes, again this is going to be b with a So on positive sign, expected value of B of t, A of t plus tau, and the last quantity is plus and minus, so you will have minus expected value of B of t into B of t plus tau. Now we will have to recollect the formula for our autocorrelation. We can see that Rx of tau is expected value of x of t into x of t plus tau. We have expected value of A of t into A of t plus tau. So in which case, comparing this with the given definition, I can rewrite this term as R. In place of xx, I have A of, what will be the time difference? T plus tau minus t. So this is going to be equal to tau. So that combines as my first term. Now consider your second term, expected value of A of t into B of t plus tau. Now we have to keep a note of the quantities that has been given to us. What have been said? A and B are going to be independent. In the case, what will happen to my E of AB? I can write this as E of A product E of B. So this is going to be my criterion number 1. Applying criterion 1 to this product A and B, what can be done? You can write this as E of A of T into E of B of T plus tau. That is going to be my expansion for the second term. Now coming to the third term, we again notice that we have expected value of B of t and A of t plus tau. Again we notice that A and B are independent, meaning B and A are also independent. Therefore this can be split as expected value of B of t into expected value of A of t plus tau. Now coming to the last term over here, we have B of t into B of t plus tau. B and B over here, x and x over here, so it is rxx. So if it is b and b over that, then we have the answer to be equal to, the last term makes it as the value to be equal to minus r. In place of x I have b, so this becomes r b b of t plus tau minus t, so the time translation is going to be equal to tau. So this is the simplification of the line which we have got on expansion. Now we will make a note of the second data which has been given to us. These random variables A and B over here have zero mean. What do we mean by it? So the quantity, second quantity which is available for us is point number 2, E of A of T is going to be equal to 0. That is mean of A is going to be 0. The second one is that E of B of T is also going to be equal to 0. A and B have 0 mean. E of A of T is 0 and B of T is going to be 0. They have 0 mean. So from the point number 2, what do we observe is that this, which contains E of A of t, becomes equal to 0. And in the second term, we have E of B of t, and this will become equal to 0. So finally, what we are left out is just R A of tau over here in front and R B B of tau over here at the back with a negative sign which is available. So moving on to the next slide, we have the value of the cross correlation R W Z of tau to be equal to R A of tau minus R B B of tau. From the given point, what do we know about RAA? It is e power minus mod tau. So this is going to be e power minus modulus of tau minus, what is going to be from your RBB? It is 3 e power minus mod tau. So it is 3 e power minus modulus of tau. So we have the answer to be equal to the final, which is going to be, this is going to be 1 times of, and this is going to be 3 times of, hence the final answer is minus 2 e power minus modulus of tau, which is going to be your RWZ of tau. So we have calculated the cross correlation between the two random processes W and Z in this way. I hope you can easily apply this properties of cross correlation to your problems. Thank you.